So let's get started. So this is a brief agenda for today. We will define what is a disaster and what is a disaster recovery strategy. What is the difference between high availability and DR? Aspects in a good DR strategy, classification of DR strategies, implementation methodologies. I think the one of the questions was raised in the previous session, like in the event of a disaster, what do I do to my server? We have manual interventions, how we go about it. I pretty much believe that I could cover some of your aspects on how you can prevent it in further. I'm not sure what's the plight right now, but maybe post this session you'll have answer to your questions. So let's start with what we can qualify as a disaster. So imagine that we heard Kishore Nalan talking about the product that he was building TypeSense. You spend days, you spend months, you spend years shaping up your product. You tell in social media that you have released or you're going to release it. And on that day, what happens is the cloud where you have hosted goes to an outage. Or there is a natural disaster as you see in the image. What happens to your product? What happens to yours? Just because you didn't take into account the small thing that a disaster may occur, be it manual or be it natural. And I choose this image because this whole session, this summarizes in one image what is disaster, how we navigate through it, and what is an essential strategy to mitigate it. All right, so anything manual or induced which causes an outage of your application and prevents it from working can contribute to a disaster. Now, oftentimes when we work with customers, many of them confuse high availability with disaster recovery. They say that, hey, if my systems are not available in this region, the customer should also be able to serve the traffic from the other region. So I thought like it may be a good point to differentiate between what is high availability and disaster recovery. So if you see on top, you have this objects placed on top. It's your object store. Now, if how many of you have worked with AWS? Quick show of hands. A lot of them. Oh, I'm so happy because most of my examples I've used is from AWS, but an object store applies to Azure also. You have the blob storage for GCP as well. So you have your object storage. It is redundant. It is available in zone 1, zone 2, zone 3. You don't have to build disaster recovery for that. If you don't get the object in availability zone, it's pretty much available in the other region as well. So there is your regional services which help you to get this. But take the condition of my writer down below. You have your RDS instance, and you know that in relational database services, there is only one writer at one point of time, right? And your availability zone 1 fails. Now, what do? Is your reader equipped enough to start serving traffic? That would be your disaster recovery. Whereas having your reader in multiple zones would be your high availability strategy. So these both are like two sides of coins. Sometimes when you design for high availability, it kind of helps you for disaster recovery. And sometimes when you design for disaster recovery, it helps for your high availability as well. All right. I know I'm covering up the screen, so I'll just go here. So, but what is a disaster recovery strategy? You know what is a disaster recovery strategy? So it is all about designing your system in such a way, like we talked about the product release that we're gonna have. What if even if your system goes down or your cloud provider goes down at that point of time, you are so well equipped that you can very well within a few hours or a few minutes, depending upon the strategy that you have implemented, you can very well start traffic from a different region altogether. So that's all about your disaster recovery strategy. Like we saw the person who was driving the car in that image, you can drive your entire workload into a different region and start serving traffic from here. And I cannot stress this point enough. Our SRE engineer was asking about the problems he was facing in that. But it is quite important that if you have to automate your disaster recovery strategy, the first thing you need to have an efficient monitoring and observability solution. We talked about Bharani, who was talking about the trends in building an observability platform. If you need to automate your DR and ensure that you can very well sleep, and if your disaster is happening, your system has gone outage, you can very well sleep because the system is well equipped to move to a completely new region and start traffic from there again. That is the core. Second thing is about testing. So unless you test your DR testing scenarios, you would never be able to emulate it, or it will never work properly when an actual disaster happens. Now, couple of reasons why customers go for disaster recovery, because sometimes some customers ask us, hey, this is an event that happens once in a while, so do I really need to think about it? But many customers have their own different reasons about it. First thing is obviously business continuity. I am launching a world-class product. I don't want my customers to have outages. In some scenarios and in some, like if you take the example of India, if you're running in an NBFC, that is non-banking financial corporation, RBI has certain guidelines for disaster recovery. So one of the customers that we are working with currently, They told us in the first meeting itself, hey, Jithin, whenever you're designing the system, ensure that it has a disaster recovery strategy also built in. That is, anything happens to my primary region, I should be able to serve traffic from an isolated region as well. So government compliance is always there, and seamless experience to end users. No matter what happens, my app will always uh, be up and running. So what are some of the aspects of a good DR strategy? So first we have the business aspect. When we talk about disaster strategy to customers, when we are doing a greenfield development, the first question they ask is, how much is it gonna cost? So again, it's like more of a rhetorical question where we ask them like, okay, but what do you want to build out of your DR strategy? Do you want end-to-end DR strategy? Say, suppose I am designing a system for a ride-hailing app, suppose like Ola, and we have a DR setup, but do you want it for all? We just want it for ride sharing. Do you want to have your trip status there? Do you want your analytics? Do you want your feedbacks? Do you want all that parts of your system into your DR as well, or just a thin slice will do? Like if the person has booked a ride, the person is able to continue it even if the system serves from another end. So that's end to end versus thin slice. And what is the business value it is bringing? If I am investing, say for one of the customers, we were investing nearly $2,000 per month only for the disaster recovery. So the customers also ask like, is it going to bring a business value into it? Is it promoting my brand? Will it really help me to stand out in the market? Will it help me fight the competition? So these are the few business aspects then government compliances already spoke about, and then region based compliance. So if you how many of you worked with European customers and you're familiar with GDPR laws? So you know that your data cannot be moved outside the region. There are region based restrictions based on that also. So when we design the DR strategy also, we need to ensure that it is within that same region. We design in such a way like that it is compliant. So for one of the customers we were working, they had asked us to build the monitoring solution, but they mentioned like, hey, we have finalized on a monitoring tool and we are good with it. Now where they ran into the problem was the tool they were using, they had the servers in US, and that same NBFC customer was based out of India. Now there is this Indian government rule like, for NBFCs you cannot have the data outside the India region. So they are in a mess right now, but we are slowly figuring it out. They are working with other tools and providers to get this done. Really important when if you are doing a cross region disaster recovery, ensure that it stays within the region. And that brings me to another important point. So this, again, another customer, they clearly told us we want a DR region in Hyderabad. All right, so here comes the important point of left shifting your disaster recovery strategy. It is not like you reach the production stage, you have all your environments, dev, QA, staging, you reach there and then you say, okay, now let me take a step back and start designing the DR system. This is what is going to happen. I'm not sure how much it's visible to you. So you see in the left side are my services in my Mumbai region, and the right side there are my services in the Hyderabad region. Now you see how many services are missing in the Hyderabad region. Now say suppose I have my service mesh set up using AWS app mesh, I'll be in a mess. There is no app mesh in Hyderabad region. Now, what am I going to do about it? All right, my code will crash. I mean, I'll run into a lot of other problems as well. You see, Hyderabad region is relatively low. So when you're designing your DR strategy with your customer, ensure that you tell, or the idea is to left shift in the design itself. When you're doing the project inception itself, bring this problem up to the table and let them know like this is what the scenario is. So we will be having these limitations. All right. Now, another point I want to have is, now we have chosen the region, we have ensured that, okay, we have all the services done. Choosing the right service also matters. So some customers say, hey, we want all the services within the cloud, AWS cloud itself. We don't want any other cloud. And we are pretty much happy with whatever solutions it's bringing us. All right. So that is a cloud specific solution. Now I will talk about what the issue of that problem is, or what the smell of that problem is when we go to the last limitations where I'm stating. But some customers say like, hey, we are okay with cloud agnostic. You be it on the cloud, but even if it's an open source solution or if it is a paid solution, we really don't mind. So here also left shifting is important because we need to ensure that to whichever region we are switching the traffic to, that region, that particular service is also available. And want to talk about a bit of a nuance on Kafka. So this happened when we built the strategy for one of the customers. We had chosen Kafka for our messaging service because we had the first solution hosted in AWS cloud, and the second part of the solution was in a different region, which was on a private cloud. Now we wanted a uniform messaging solution. So there, but we ran into a lot of nuances because they were again mapping that to a cloud agnostic solution. So we have the managed streaming for Kafka using AWS, but when we are building the authentication and authorization for Kafka, how many of you have worked with Kafka? Yeah, so you know how difficult it is if there are two environments and we need to have the secrets encrypted. Take those secrets, use the same secrets to connect to a Kafka in the another region, have common topics between them, link those topics, have the same data topic replicated. We ran into a lot of issues, to be honest. So what I'm saying is, I'm not saying that don't use Kafka there, but be aware of these nuances when you are designing your DR strategy for your customer. When you're estimating it, have it in mind what is the complexity of services that you're using. Now we briefly go to the DR configuration. So before we go to the DR configuration, I shortly want to mention about regions and availability zones. So some services that we use are region based. Say for example, you have your API gateway, you have your Amazon ECR, so they spread across the region. Like I previously mentioned, we don't have to build redundancy into it, but some services we have to make it available across within the region itself. There needs to be built in the redundancy. So this apply to all clouds also, not only AWS. I've just used the AWS example here. So I have categorized the DR strategies into three major ones. So first we have based on region. We similarly spoke within the region and cross region. Based on RTO and RPO, I think we will be talking extensively on this. So I'm not double clicking on it right now. And then there is based on cloud providers. Some customers say, we don't want it restricted to say, suppose AWS goes down, still my workload should be running in Azure as well. So we are not double clicking on this in this session because it's a big session in itself. But I just wanted to let you know that there is a multi and distributed cloud strategies as well. Say one of the customers we are working with, they have a distributed cloud. So they have their identity in Azure, they have their legacy system in Oracle, and they have their main application in AWS. Now imagine designing the disaster recovery for such a cloud, multi-cloud solution. It will take me 1 or 2 hours to explain how each layer can be done. So in the interest of time, we are not covering this thing, but maybe in some other later session. All right. So based on region, very simple. AZ level, you have your availability zone. Something fails, it goes to the next level. Cross region, the entire region. Mumbai region fails, Hyderabad region is up. As simple as that. I'm just rushing a bit because we have few couple of demos as well. Now configurations based on RTO and RPO. So this is the heart. Whenever we discuss strategies with the customer main question they ask is, hey, how long the app is going to be down? How much time do I have? And how much data can I lose, or in what time the data will come up? So based on this, we have three major configurations as we see. Some customers, if their systems are not very critical or they're not very keen on spending for DR strategy, they say, we are happy as long as our data is backed up somewhere and in some form of the other it exists, and whatever requests are coming in, we are having a queue somewhere and we are capturing it, and we are okay. I mean, it's not very critical for us to invest in this, so we are fine. Very easy to implement. If you look at cloud services, there are out of the box services available for this, for backing up your stateful systems. Now, this is one of the most common strategies which most of the customers whom we have worked with come to. It's about active passive. So it's like you have your active system in one region, but the system, the entire application workload is available in some other region. Say you have your Kubernetes cluster set up on your worker nodes. It's running in your primary region, Mumbai. The customer says like, hey, I want the same workload in Hyderabad region, but I don't want to start my servers. The servers, let it be in the stopped state. All right, the databases, let it be in a stopped state. I don't care. When the disaster happens, I can afford to lose a couple of hours. I mean, it's okay. I mean, I'll incur a cost, but I don't want to keep it active and occur. So the complexity is a little bit medium, if you ask me, because you need to again create. But again, like we had in the previous session, if you have done good in your infrastructure as code, it's just you need to run your make file, you're sorted. Now, this is the most toughest one, and we'll be having demos for this as well. The active configuration. So when we were working with one of the customers in North America, there was same the business aspect and there was a compliance aspect also to have an active solution. It was also for a road transportation provider, and they also told us, hey, ride sharing should never be stopped in between. No matter what happens, the show must go on. All right. So if the person has booked a ride and your system has gone down there, the person cannot be kept waiting for long. Maybe a few minutes here and there. We agreed that okay, 10 to 15 minutes we can agree, we can design it for you. So that is a configuration that we had applied. It's for active, really complex. You take front end, it's okay, but you take back end, it's not. It's somewhat okay, but you take database, you will know how difficult it is, and the messaging as well. All right. So that's why like the front end and the database is what I've chosen for demo as well. So DR implementation. So here also there are a couple of ways to do about it. So sometimes customers don't want to play with the automation. They say like it's okay, like as long as we get the disaster recovery notifications, we'll push the switch ourselves. That is manual, which is acceptable because the customers don't want false positives. Say you have your automation, you have your automated system built, and say suppose one service goes down, two service goes down, but maybe it was a temporary AWS outage which happened for only a few minutes, but you didn't cover that aspect when you built your monitoring and observability. You told that if the alarm goes down for only 5 minutes, just apply the DR strategy, move to another region, but that was a false positive. All right, because it was not a disaster, it didn't prolong for that long. So that's why some customers say that hey, let's make it manual. Automation we can always build it later. And then obviously there is the automated one. So front end. So we have the front end. This is a general template. I guess it applies to all cloud providers as well. You have your users, you have your DNS resolver, you hit www.abc.com. It's advisable always to have a content delivery network, but some customers they say like we don't want to invest it, let's you directly point to my origin. But where a CDN helps us, a CDN can map to different origins in region A and region B, so that if one region is down, another region can start serving the traffic. So this is the double click on it and the implementation using AWS. So Route 53 is your resolver, CloudFront is your CDN, and I've used CloudFront, but you can use any third-party CDN for that matter. I have a primary region in US East 1, I have a secondary in US West 2. So we will see this in demo shortly, so I'm not moving. So I request for origin A, it's not available, we go to origin B, as simple as that. So I have used very simple files here in the demo, but in the actual implementations where we have done this with React applications also, fully blown front end, it works the same. So here, okay, let's see the demo first. Maybe I'll start after that. Can we have the demo, please?
Hello everyone. So let's move ahead to the CloudFront dashboard.
Sorry, you have to keep seeing my face for some time.
All right. So we have the CloudFront distribution over here. So this is my distribution name. And when you run this, so I have nothing complex. I have two buckets in Hyderabad and in Mumbai region. So my Hyderabad serves as my primary region, and I have a HTML file here which emits welcome to DR strategy from Hyderabad. I have a Mumbai file which says welcome to DR strategy from Mumbai, so as to recognize which region is serving the traffic. In an ideal scenario, both these files will be identical, but for the demo purpose, I have made it like this. All right, so if you look at it, I have a Hyderabad bucket. Again, I have two files there, and Mumbai region is same as well. So in order to emulate the scenario of failover, what I'm going to do is I'm going to forcefully delete one file so that when CloudFront looks for that file, it does not find it. So if you look at the CloudFront distribution, it has two origins in Mumbai and Hyderabad. And also I've created the origin group, which helps me to failover. And I've selected the failover criteria if it is a 400, 404, 500. And it's quite essential that we choose all of them, because when a disaster happens, you never know like what the service is returning or what error it returns. Is it a 404 error, or is it a service unavailable error 5003, or is it an internal server error that the service is not able to serve requests, or does it get timed out? So we're not quite sure what happens in disaster based on the nature of the disaster or the outage as such. So this I have set keeping all this in mind. So let me go ahead and change it. Now let me go ahead and emulate this behavior. So now we see that we have the index.html being served from the Hyderabad bucket. So I will go ahead and I will delete this file. It's asking me to permanently delete it. So this gets permanently deleted. I delete the objects. It's fine now. So now I don't have this file. But if I refresh this again, from the CloudFront cache, it will start serving the traffic. So what I need to do here is I need to do an invalidation to ensure that the content is not cached. So in a real life scenario, this when this happens, or when your cache time expires, it will automatically search for the new content, and then when it is not found, it will automatically fail over to the region that you have allocated. But here, for demo purpose, I'm invalidating the cache. So let's give it a couple of minutes for the cache to get invalidated. Depending upon the number of regions you have, uh, the cache invalidation will take its own time. So now I have put it only in the Asian region for now. So the invalidation happens at the all edge locations in a certain amount of time, and we are able to see the results. Now, if I go back and if I run this, it will start serving traffic from the Mumbai region. Now, if the DR.
So again, there is a second part, but I don't think we have enough time for that. What I have done in the second part is we again serve the file back to Hyderabad, and once you start hitting the URL, it comes back to Hyderabad by itself once the file is available. So this can both be used as a high availability and a disaster recovery strategy as well. And also kindly note that your objects needs to be replicated across both regions when you are applying this to the front end. Otherwise, what happens is you make some changes to one system. Say he was saying like during disasters we make changes to some system and it doesn't get reflected in the other one. So ensure that bucket replication or replication of objects across region is set up. That's one caveat to watch out for in this. Now backend is again the same. You have your APIs, you have your API gateway, and the DNS resolver always talks to the health check. Now, how do we identify that it is a disaster and it is not a false positive? That is how where your health checks matters. So all the health checks that you're running, you cannot identify. Say suppose only your API gateway gone down, that does not become a disaster. You need to check your front end, back end, API, DB, keep polling it for a prolonged period of time, have all the health checks cascaded. Only then you will be in a position to evaluate and say like, or your system would recognize it as a disaster. Otherwise, you will be switching back and forth between regions. You will be incurring unwanted costs. Your systems may also not work as intended. So this is an AWS level implementations for it. You have a Route 53, you have a Route 53 health checks. Healthy route, your EKS clusters in your left. Unhealthy route, once it's gone, it starts serving traffic from the other region. Now, a little bit about auth. So this was also a tough nut to crack. Previously, I told like when we work with cloud specific solutions, they come with its own limitations. Now, one of the limitations we faced with Cognito was Cognito, if you have, how many of you have worked with Cognito? Yeah, many of you, right? Cognito has an issue. It's an identity server for those who are not aware of the AWS. It's an identity server provided by uh, AWS. So here we have user pools. Now user pool is where you persist. Say suppose you create your username and password. Your user pool saves all those data. And if a disaster recovery happens and you move to another region, what will happen? You try to log in, but you cannot migrate the passwords when you're migrating user pools to another region. So when you're building your DR strategy, your passwords are not existent. Now you move to Hyderabad region, a disaster happened, you try to log in, guess what? You're not recognized by the system. So we had to build a workaround for this. So what we thought about was we came up with this architecture, wherein which we, in the initial phases we will direct the user to the DR regions user pool. We have a Lambda trigger. So there is a pre-built trigger by AWS. So whenever the user tries to log into that, it will trigger the Lambda auth trigger. And from the Lambda, it will get the authentication details. It will pass the code and it will get the username and password and it will persist it to the Cognito pool. So you could see it in the next. I'm not sure if it is readable or not, but this is the code at high level. And I really enjoyed working on it because from an architect, I was a dev when we designed the solution. So again, I have used Python here. So simple, there's a Lambda event handler. It gets your event and you can do it for your login as well as for your forgot password also. And we pass it for username and password and persist in the other region. Now, but this was not always possible. So one flow we came for one of the customers was whenever the DR happens to a new region, we ask the customers, because what happens in this flow, I'll tell you, you move it to the DR, everything persists fine. But one of the solutions, one of the customers proposed to us was to have a forgot password flow. So that also applies to this architecture. So when we have the forgot password, what happens is in the new region, the new password gets fed into it, and as long as the DR is happening, the user is able to log in. But again, this problem happens when the user, after the disaster, once you come back to the main region, then it's no longer the same new password is not transferred. So then again, you need to write scripts to move it back. So that was one caveat for that. But this solution works as long as you're connecting it to the DR first, have the users onboarded there, and then move back and front. All right. So running short of time. So now this is the toughest part we have. How do you implement DR for your databases? Has anyone implemented disaster recovery for databases? Quick show of hands. Oh, you have. Well and good. Was it a relational database or was it a NoSQL? Okay, cool. So this one is about having it in an automated way. We can always do it in a manual way. We can just push it. But how do we automate this? So what is really happening here is your health checks and notifications are really important. And to have a failover, you need to write the scripts to ensure that your primary and secondary needs to be changed. So I will quickly tell what I'm talking about. So I've used Aurora Global DB to implement this. Now I have it in my primary Mumbai region and say I have it in my Hyderabad region. Now, RDS I have already mentioned, you can have only one writer at a time. So if my writer is serving traffic from the main region, and if disaster happen, it should start serving traffic from the second region, and the Aurora in my Hyderabad region should also be promoted to a writer instance. Now, how do we go about this? So one solution we came up was AWS has some service called as RDS notifications. And why we had to come up with this solution is because we had to use that solutions, we had to use that notifications, and on that notification there is a SNS topic that is being it publishes to, which talks to the Lambda, which will give that same event. And we had to parse that event, and we had to keep polling that event multiple times to see, to ensure that it's not a false positive, and only then trigger the failover through the scripts. Then you will have your primary instance, which was a read-only instance before, get promoted to the writer instance, and then start traffic from here. So now comes the problem. Now what has happened is you have a global cluster, you have a primary, you have a secondary. So once your secondary gets promoted to your primary, it needs to get detached from your global database, because it can no longer keep sending traffic back to that region. So now your primary is here, your secondary is there, but your secondary gets detached. Now the funny thing, what I know I'm talking a lot of things, but funny thing what happens is, now till here it's straightforward. Disaster happens, it becomes your writer. Now what happens when the disaster is over and you're back to your primary region? All your applications are there, but your database is still sitting in your secondary region. Now again, what you need to do is you need to again create a replica in your cross region replica of your primary in there, again trigger the failover, and then come back to that region, and then again that becomes your primary, and that then this will become your secondary. Quite a complex flow. We'll see that shortly in demo, but keep these points in mind. Data should be synchronized continuously. Script must be written, thoroughly tested as well. Testing, you cannot escape it no matter how you do it. All right, so we'll have the demo. I don't think we have much time. Maybe we will do a, can we have the demo maybe quickly?
Hello everyone, and here we have the database setup for our global database. So I have my primary in AP South 2, that is the Hyderabad region, and I have the replica in AP South 1, which is nothing but the Mumbai region. As you could see, there is a global database and it has two regions, and based on the primary and secondary, the failover will happen. Now, how we do failover here is we need to have two records, one for your primary and one for your secondary, and they will both should map to a single record name. And based on the routing policies that we apply, we can always switch back and forth. So in case of a disaster, you see that I have this mydb.database.myglobalApp.com. So in case of a disaster, if one of the value is not available, that is my primary is down in AP South 2, then the end users don't have to change the URL. Under the hood, Route 53 will route the traffic to this new region. But for now, I have kept the weight as 1 and 0. So currently this mydb.database.myglobalApp will resolve to this particular DB primary AP South 2 cluster, which you could see from here is my primary cluster. So let's see if everything is working as expected. So I've opened a Cloud Shell. So kindly note that I have used here internal private hosted zones. So I need to have a bastion host inside the VPC. Only then my queries to resolve this particular domain name would resolve. But in an actual scenario, also you need to have this, because otherwise you will have to allow public traffic from instances outside your VPC or outside your system. But if there is a network issue and you're not able to route traffic, then you will have to check your security groups with respect to databases. Ensure that SSH access is enabled. Only then you would be able to SSH into the Bastion host and then probably reach your database service. So here I'm getting into the mydb.database.myglobal.com. So ideally it should resolve to my primary database. So it is working as expected. I have my DB primary AP South 2, and that is what it is getting resolved into. And this is nothing but my primary instance. All right. Now, what we can do is there are many ways to do it. So what we are going to try now is we will first try if our switch over or if
Nothing major here. I'm just
all right. So this
ensuring
is
that
to allow
the weights are
consistency
correct.
across the
So we can just fast forward a little
database,
bit.
across the regions. All right. So now that we have switched, best case scenario, it is always recommended that you detach this secondary cluster from your global database, make it exist as a primary database, because anyway the replication is not going to be successful. All right, so I will pause my recording here because this takes a certain amount of time. Let's resume back once
So I have triggered the
it
failover
has
now. Now
finished
let's
failing
see
out.
what happens.
All right, so it roughly took around 4 to 5 minutes, and now, as I mentioned, this has become my primary cluster, and my primary has now become a secondary cluster. And if you look at the cluster also, the previous cluster, which was inactive, is now in the available traffic, in the available state, and is ready to serve traffic. And if you go to AP South 2, which was our primary, is gone now in active state. Now, in ideal scenario, what you should do is you should go ahead and detach this and make it as a standalone.
So I guess you have seen like how it is between switching over from one region to another. So the further up in the demo, I switch back to the primary region again once the disaster is over, but I don't think we have enough time for that. All right, so I leave it for questions.